Okay, let's talk about inverse linear functions. The first thing we need to know is what is an inverse relation. And an inverse relation is the set of ordered pairs obtained by exchanging the x coordinates with the y coordinates. For each ordered pair. Okay, so that means that if I have my original things, we'll call in column A, and then I'll put my new column things, my inverse, in column B. So let's say I have the point -3, -16. When I take the inverse of them, I'm switching the x coordinate with the y coordinate. So I'll have -16, -3. Okay? So again, and I can do this with as many ordered pairs as I want, as long as I switch every x with every y. So -1, 4 becomes 4, -1. So let's try this with an example of several ordered pairs in a row. So 4, -10, 7, -19, -5, 17, -3, 11. So go ahead and find the inverse of each pair, and again you're writing it just as the inverses within those brackets. Let's go ahead and try that. Good, so my inverse should be -10, 4, -19, 7, 17, -5, and 11, -3. Okay. We can also find inverses when we go graphing. So I'm going to start by drawing my coordinate plane. Okay. And let's say I have some points that they give me, 0, 1, -2, -1, 3, 4, and -4, 3, -3, sorry. And I want to find the inverse of each one of those pair. Okay, so go ahead and find the inverse of each one of those pairs. Good, so if you're filling in that inverse column, you have 1, 0, -1, -2, 4, 3, and -3, -4. Okay, so I'm going to plot my original points in blue and my inverse points in pink. So my first point is 0, 4, so that's here. My next point is -2, -1, so right here. My next one is over 3, 4. And my last one is over -4, down to -3. So here. And I draw a line to connect them. The line more or less passes through all those good points. And so then I graph my inverse line. So now I'm looking at 1, 0. And -1, -2. And 4, 3. And -3, -4. And I have a line that is not my original line. It's the inverse line. And this one happens to be parallel just because of the points I picked. inverse graphs are not always parallel. Okay, sometimes they will intersect. Okay, so I know last year when I graphed some of the examples in the classwork, you would have lines that looked like this. Those were the inverses, this line and this line. So they don't have to be parallel. They don't have to always intersect. They can kind of do either or. Okay? So beyond graphing and just switching the points, we can also find the inverse of a function. Okay? So remember, sometimes we write functions with the f of x. So let's say I have f of x equals 4x minus 8. So the first thing I'm going to do is I'm going to write f of x as y, because that's a little less confusing. But I will go at the end put it back in that f of x format. And remember, inverse is all about switching the x and the y. Okay, so I'm literally, as my next step, going to switch the x and the y. But this is not how we usually write equations. And in fact, if I plug f of x back in for y like that, it's not going to make a lot of sense. So I need to solve for y. So I'm going to manipulate this equation until I get y by itself. So the first thing I'm going to do is I'm going to add 8 to both sides. So that I get x plus 8 equals 4y. Now I see that y has this 4 next to it, so I'm going to divide by 4. So eventually I will get that y equals x plus 8 over 4. Or if you wrote it 1/4 x plus 2, that's the same idea. And then like we said, we're going to write it back in f of x format. So f of x equals x plus 8 over 4, or f of x equals 1/4 x plus 2. Okay, so there were some steps that we followed here. This first step, moving down, was to change f of x to y. My second step was to switch x and y, or interchange them if you want to get fancy wording. Oh. And then my last thing I did, going down to all these steps, was to solve for y. Get y by itself. Okay? And we one thing I failed to mention, because this is the inverse, instead of just f of x, I actually write f inverse of x, so f to the negative 1. Okay? That's important, and I forgot to mention that, and I'm sorry. And that is our fourth step. Change y to f inverse of x. Okay? So let's try another one of those together. So we'll start with f of x equals negative 1/2 x plus 11. What is my first step going to be? Good, I need to change f of x to y. And once I've changed f of x to y, my second step is going to be to, good, switch the x and the y. Interchange them, if you will. Okay, and then I should be ready to go ahead and solve for y. And I'm going to do that by subtracting 11 on both sides. So I have x minus 11 equals negative 1/2 x. I'm sorry, y. Whoops. And then to get rid of the negative 1/2, I multiply by its reciprocal, which is negative 2. So that I get y equals negative 2 times the quantity x minus 11. And if I distribute that, negative 2x plus 22 is equal to y. And I have one final step, and that is to, good, change y to f inverse of x. Okay, so try this last example completely on your own. We'll start with f of x equal to 1/3 x plus 7. So go ahead and check your answer with mine, check your work, make sure you have all the right steps, and I will see you next time.